Hi everyone, this video is on the mixed exercise 9 question 33. So we have the curve with the following equation, and there are two distinct points on the curve, and each of the points have the gradient 2 over 11, and we want to use the implicit differentiation to show that the straight line passing through A and B has equations x plus 2y is equal to 0. Okay, so what this means is that we have a curve, maybe something like this, and there are basically two different points on the curve, and maybe let's say here and here, for example. This diagram is not accurate, but just for visualization. Let's say that the gradient at these 2 points is 2 over 11. And what we want to show is that we want to show that the straight line that passes through points A and B has this equation. Because the 2 points have the same gradient, so that's why that there is a straight line that passes through them, and the straight line obviously has the same gradient as that part of the curve. So here the idea is that we need to differentiate and then set the derivative equation equal to the gradient. And because that's how we normally find the gradient, right? We first find the derivative and then we substitute the coordinates into that. So in this case, this is implicit differentiation, and 7x squared, let's differentiate this. So 7x squared differentiates to 14x, and 48xy is the product rule because we have two functions. So let's say the first function is 48x, the second one is y. And the first function is 48x times the derivative of the second function, which is just dy by dx. And now this first function differentiated times the second function, so it's going to be 48 times y. And now minus 7y squared differentiates to minus 14y divided by dx, and 75 differentiates to 0. Okay, now we can take a factor of dy by dx to have dy by dx in terms of x and y. So dy by dx times 48x minus 14y is equal to, let's move everything else to the right hand side, minus 14x minus 48y. And now let's divide both sides by this bracket on the left hand side. Dy by dx is equal to minus 48x, sorry, minus 48y, then minus 14x over 48x minus 14y. So it's interesting on its own right that we have the different combinations of x and y, and then also some 14 and 48. But anyway, so now we have this. So the next thing that we should notice here is that the gradient, this is the equation of the first derivative, and if we substitute the coordinates of points A and B, we are going to get the gradient of 2 over 11. So that's the key part here. So this means that if we set dy by dx equal to the gradient 2 over 11 and then simplify that, we are going to get something interesting. So let's do that, because if we do this, this allows us to find the coordinates of the points if we want, even though the question is not about that. But let's do that here. So this is a simple cross multiplication, and we first multiply 11 by the numerator, which is minus 48y minus 14x, and then 2 times the denominator, which is 48x minus 14y. Okay, at this point we just need to expand this bracket first. So the left hand side is going to be minus 528y and minus 154 x is equal to, then the right hand is 96x minus 28y So we can now simplify it. So let's move everything to the left hand side. We have minus 528y, then plus 28y, and also minus 154 x minus 96x is equal to 0. Then simplifying it, we get minus 500y and minus 250x is equal to 0. So we can divide everything by 250, and we are going to get minus 2y minus x is equal to 0. Let's multiply by -1 to have the positive equation, which is 2y plus x is equal to 0. And this is exactly what the question was asking, to show that the straight line passes through A and B, and the straight line has the equation x plus 2y is equal to 0, which is exactly what we wanted at the beginning. So now you might be asking, how come I chose to just set the derivative equation equal to the gradient and then keep simplifying until I get the equation? What if this wasn't the method? So sometimes the best thing that you can do in questions like this is that when you have differentiation, and then the question is about differentiation and then gradients and even maybe the equation of tangent and things like that, maybe 90 or at least 80% of times the procedure is the same. Basically, you just find a gradient, then you find the equation of the first derivative, and then you try to find a gradient. Sometimes the gradient is given to you and you set that equal to the gradient, and sometimes you try to find the coordinates. So it's always usually one or more of these methods that you need to always remember and try to solve the question by using those. So yeah, that's how I did. So I found the derivative and then set that equal to the gradient, and I just kept simplifying. And when you get to this point, then you can also continue and find the coordinates, but that's not what the question is asking. So yeah, always remember these methods. Even if you don't have a clear idea of how you can tackle the question, as long as you try these methods, you will probably get something out of it. So yeah, that's it for this video, and thank you for watching.